The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to wrap up section 1D, and if all goes well, we'll go ahead and cover 1E as well. We'll see what happens. Anyway, something that I discovered the other day because one of you asked about it that I was not aware of on WAMAP. After an assignment is past due, you can go back to that assignment and you can still practice. You can't change your grade on the homework, but you can go back in and do more problems and it will, tell you whether you're correct or not. So that's a good way to review and everything. And I see you shaking your head, so you've discovered that as well. Anyway, like I said, this is WAMAP is new to me, so I'm still discovering things about it. Anyway, okay. So we're going to pick up where we left off yesterday. And that is with the following problem. It says add. We have 2/3 plus -7/8. So we can't add or subtract fractions unless they have the same common denominator. So we need to find the common denominator of 3 and 8. Some of us can look at it and say, oh, it's 24 and move forward. Others of us may need a little bit more work. Let's take a look at 3. 3 is a prime number. So the prime factorization of 3 is just 3. 8 is not a prime number. If we do the prime factorization of 8, 8 is 2 times 4, which is 2 times 2 times 2. So I believe I said yesterday, the least common denominator is the product of the highest power of each different prime factor within either one of the original denominators. So the highest power of 3 is just 3 to the 1 power. The highest power of 2 in this case is 2 to the 3rd power, 2 times 2 times 2, which is 3 times 8, which is 24. So in this case, it ends up just being the product of the two denominators. So now what I need to do is change 2/3 into something over 24. So I need to multiply the denominator of 2/3 by 8. 8 times 3 is 24. Then I have to multiply the numerator by the same number, 8, so that in fact I'm just multiplying by 8 over 8, or just 1. So my new numerator becomes 16. So basically 2/3 becomes 16 over 24. Those are equivalent fractions, but 16 over 24 has the denominator we desire. Okay. All right. -7/8. I need to multiply the denominator by 3 because 8 times 3 is 24. Consequently, I need to multiply the numerator by the same number. So my new numerator here becomes 21, or in fact, -21. So we took 2/3 and built it up to 16 over 24, -7/8 and built it up to -21 over 24. Now that I have two fractions with the same denominators, I can add or subtract those fractions. So let's see here. We've got 16 plus -21. Well, 16 plus -21, let's see, we would take 21 minus 16, which is 5, but the negative was larger. So this would give us negative, or I should say more powerful. So this would give us -5 over 24. That won't reduce further. So that would be the final answer. Okay, how are we doing there? We okay with that problem? I'm seeing a little bit of positive nodding. Okay. Michael, you made it. Good job. Good to see you. Okay. Let's take a look at this next problem. 6 5/9. Oh, excuse me, not right. 6 5/6 plus 8 1/9. Well, I could add the 6 and the 8 as whole numbers and get 14. But to add the 5/6 and the 1/9, I can't do those yet because they don't have a common denominator. So the question is, what's the least common denominator of 6 and 9? 6 is 2 times 3. 9 is 3 times 3, or 3 squared. To find the least common denominator, I take the product of the highest power of each different prime factor that is in either of the original denominators. I've got 2 times 3 and 3 squared. 2 is 2 to the 1 power. There are no 2's in 9, so we've got 2 to the 1 power, times I've got 3 and 3 squared. 3 squared is the highest power of 3 in either of the two denominators. So I've got 2 times 9, or 18. Okay, so 18 is the least common denominator of 6 and 9. So 6 and 5/6 becomes 6 and so many 18ths. I'm just going to change the fraction part. 8 and 1/9 becomes 8 and so many 18ths. Okay, so I'm going to take 5/6 and multiply it by 3/3, and 5/6 becomes 15/18. So 6 and 5/6 becomes 6 and 15/18. I'm going to take 1/9 and multiply it by 2/2. 1/9 times 2/2 becomes 2/18. So 8 and 1/9 becomes 8 and 2/18. So now I can add all the different parts. 6 plus 8 is 14. 15/18 plus 2/18 is 17/18. 17/18 doesn't reduce, so this would be my final answer. Any questions about that example? All right, let's say we've got 7 3/5 plus 4 3/10. Basically, this is the same scenario we had before. We're adding two mixed numbers. We can add the whole number parts. 7 plus 4 is 11, but we cannot yet add 3/5 and 3/10. We need a common denominator. So we need a common denominator, or the least common denominator, of 5 and 10. 5 is prime, so its prime factorization is just 5. 10 would be 2 times 5. So my LCD, I need the highest power of 2 that's up there, which is just 2 to the 1 power, times the highest power of 5 that's up there, which is 5 to the 1 power. Now, you don't combine these, you just take whichever one is highest. In this case, it's a tie, so we can use either one. So the LCD is 10. And again, if you can look at this and see that, oh, the least common denominator is 10, then you don't need to go through this process. Okay, so this is going to be 7 and so many tenths plus 4 and so many tenths. It ain't broke, don't fix it. So 3/10 stays 3/10 rather. 3/5 we're going to multiply by 2/2 to get 6/10. So I've got 7 and 6/10 plus 4 and 3/10, which is 11 and 9/10. 9/10 won't reduce, so there's my final answer. Any questions about that problem? Okay, let's take a look at this next problem. We have 11/8 minus 5/8. We're subtracting two fractions. They already have the same denominator, so we subtract the numerators over the common denominator. 11 minus 5 is 6, so we get 6/8. However, 6/8 will reduce. Both of them are even, so we could divide the top and the bottom by 2 and get 3/4. 3/4 won't simplify any further, so that would be our final answer. Any questions there? All right, Next example, we have 3/4 minus 2/3. We don't have the same denominator, so we need to find the least common denominator of 4 and 3. 4 is 2 times 2 as its prime factorization, and 3 is just 3 because 3 is prime. So we need the highest power of 2 times the highest power of 3. So in this case, it's the product of the two denominators. That's not always the case though, okay? So I've got so many 12ths minus so many 12ths. To change 4 into 12, I've got to multiply it by 3, which means I also have to multiply the numerator by 3. So my new numerator is 9. The best part about this is you get to say new numerator. Okay, maybe that's not the best part. Well, I think it's fun. Okay, 2/3, you got to look for the little pieces of joy wherever you can find them. All right, we're going to multiply 2/3 by 4/4. So I get 8/12. 9/12 minus 8/12 is 1/12. So there's the final answer of that problem. Okay. Any questions there? All right. 7/15 minus 3/10. So I need the common denominator, the least common denominator of 15 and 10. The prime factorization of 15 is 3 times 5. The prime factorization of 10 is 2 times 5. So my LCD consists of a 2 times a 3 times a 5. The highest power of each different prime factor within each different original denominator. 2 times 3 is 6 times 5 is 30. So my least common denominator is 30. So I've got to multiply 15 times 2 to get 30. So 7 times 2 is 14. So 7/15 gets built up to 14/30. Second fraction, I need to multiply 10 times 3 to get 30. So I need to multiply the numerator 3 times 3 to get 9. So 3/10 becomes 9/30. Now that I have two fractions with the same denominators, I can add, or in this case, subtract the numerators. 14 minus 9 is what? 5/30. But we're not done because 5 goes into 5 and 5 goes into 30. Let's divide, whoops, that's not what I wanted to do. Let's divide the top by 5 and the bottom by 5. 5 divided by 5 is 1. 30 divided by 5 is 6. Okay, so we get 1/6. Let's take a second look at that. Another way we could look at it is we could say 30 is what? 2 times 3 times 5, because 30 is 2 times 15, 2 times 3 times 5. So we could break them down into their prime factors. Then we could come back and say 5/5 reduces to 1/1, and we get 1/6. So we can do it that way as well. Any questions about that example? Okay, here comes another one. 19/24 minus 5/8. Well, can you see that 8 goes into 24? So 24 is going to be the least common denominator. Are you okay with that? Just jumping to that conclusion? Okay. It ain't broke, don't fix it. It's broke, let's fix it. So we need to turn 8 into 24. So we'll multiply the denominator by 3 and the numerator by 3. So the new numerator becomes 15. So now I have two fractions with the same denominator. Subtracting the numerators, 19 minus 15 is 4/24. Well, 4 is 2 times 2, and 24 is 2 times 2 times 2 times 3. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. That's how I got there. So now I can come back and reduce 2/2 is 1/1. 2/2 is 1/1, and I have 1/6. Now again, if you can look at this and say, well, 4 goes into 4, and 4 goes into 24, and do it that way, that's fine as well. Either way works. It's just a matter of whether you can see what numbers to use or not. This exposes everything to see what's common. This is just kind of chipping away at it, and that works as well, as long as you don't miss something there. Okay, let's see here. Moving on. -3/8 minus 5/7. Well, there's two big things I need to do here. I need to change subtraction to addition of the opposite, and I need to get a common denominator. And it doesn't really matter which thing I do first. I'm going to go ahead and get the common denominator first. Well, the common denominator of 8 and 7, 8 is 2 times 2 times 2, and 7 is just 7. So basically, we need the whole thing. Okay. Again, they don't share any common factors. The product of the two is going to be the least common denominator. So I'm going to have negative something 56 minus something 56. I'm going to multiply the 8 by 7. So the 3 by 7 is 21. So -3/8 becomes -21/56 minus, I'm going to multiply the 7 by 8 and the 5 by 8. So the new numerator is 40. So 5/7 becomes 40/56. Now I'm going to change this into addition of the opposite. Subtracting a number is like adding its opposite. I'm adding two numbers with the same sign. -21 plus -40 would be -61 over the common denominator. Well, then the question is, will that reduce? Well, let's see. 56 is 2 times 2 times 2 times 7. I know that from right there. 61 or -61 is not even. So 2 doesn't go into 61. Does 7 go into 61 evenly? Let's see, 7 times 8 is 56, remainder, no. So the numerator doesn't contain a 2 or a 7. So even if 61 is not prime, when in fact it is, but even if it isn't prime, it doesn't share a common factor with the denominator. Therefore, it won't reduce, and this is our final answer. In other words, for this thing to reduce, there would have had to be a 2 or a 7 as part of the numerator. Okay. All right. Here we go.
Mr. Mayo,
Yes, ma'am.
my brain automatically wants to make that -1 and what, 5/56? Do we only ever do that when it asks for a mixed number?
A simple answer would be yes. If it asks for a mixed number or if it's appropriate. Let me give you an example. When you go to the fabric store to buy some cloth, would you buy 9/3 yards of cloth or would you buy 3 1/3 yards? Right. So there, the mixed number would be appropriate. They're equivalent. There's nothing wrong with the 10/3, but it would be appropriate to use a mixed number there. Okay. Does that kind of give you an idea? It isn't that one is right and one is wrong, but if they specifically ask for one, use it. If they don't, then either should be correct. One of the things I wanted to mention also to y'all is be careful to look at, there are instructions sometimes written below the problems. For instance, there's another format that I'm using on a different class. It's called WebAssign. In WebAssign, it will not accept mixed numbers. You can't use them. You have to use fractions. In this, I believe you can use mixed numbers if it says not to, or if it says to, but it tells you what to do. In fact, I'm looking at some problems that I'm going to be doing here in a minute, and in the directions it says not mixed numbers. So in those cases, you have to avoid it. When all else fails, read and follow the directions. Okay, I know. It's like you're used to, well, some of you perhaps were taught in a previous class, always change a mixed number into an improper fraction into a mixed number. And as we move into algebra, that's no longer so. I know that's frustrating. Okay, I've blabbed about that enough. Here we go. Maybe, there we go. All right, so -1/10 minus -1/15. Two things I need to do here. I need to get a common denominator, and I need to get rid of that double negative. I'm going to go ahead and get rid of the double negative this time first. So this would become -1/10. Subtracting a negative is like adding a positive. So -1/10 plus 1/15. We okay so far? All right. What's the common denominator? Well, 10 is 2 times 5, 15 is 3 times 5. I need a 2, I need a 3, and I need a 5. So my least common denominator is 30. I'm going to multiply 10 by 3, so 1 by 3, so 1/10 or -1/10 becomes -3/30. I'm going to multiply 1/15 by 2/2, so 1/15 becomes 2/30. So -3/30 plus 2/30 would be what? -1/30. Okay, we all right with that? So Mike, I see that you're standing on your head. Does that help you have the blood rush to your head? Does that make it better? Okay, whatever works for you, man. All right, let's go on to this. Okay, 5 7/20 minus 1 2/5. Okay, I need a common denominator of 20 and 5. Can you see that the common denominator would be 20? So this is 5 7/20 minus 1 and so many 20ths. I need to take the 2/5 times 4/4, and I get that. Well, 5 minus 1 is 4, but 7/20 minus 8/20, we've got a problem there because we're trying to take away more 20ths than we have without borrowing from the 5. Now, there are several different ways of approaching this problem. I'm going to just give you the one that is probably the least complicated to follow. What I'm going to do is take each one of these mixed numbers and change them into improper fractions. So recall from yesterday, to take 5 7/20, we take 5 times 20, which is 100, plus 7, which is 107 over 20. Okay, minus 1 and 8/20. 1 times 20 is 20, plus 8 is 28, so 28/20. Okay, so now we're going to take 107 minus 28. So we're going to borrow and carry. 17 minus 8 is 9. 9 minus 2 is 7. So I've got 79 over 20. Now, here is what I would say. Unless the directions say not to use a mixed number, because the original problem was mixed numbers, I would think it was appropriate to change this into a mixed number. That doesn't mean that an improper fraction is wrong. It just means that following the example of what we started with, I would go back to that. Okay, so 79 divided by 20 goes in 3 times and 19/20. So final answer, 3 19/20. Again, unless it said don't use a mixed number, and then you'd use that. Okay. All right, we're going to look at one more of those. 4 13/18 minus 1 5/9. Common denominator here is 18. Everybody okay with that? Okay, so that remains, and this changes into 18ths. We've got to multiply 5/9 by 2/2, so 5/9 becomes 10/18. Now here, we're taking away less 18ths than what we have. So in this case, we wouldn't have to change it to improper fractions. We could, but we could say 4 minus 1 is 3, 13/18 minus 10/18 is 3/18. Okay, you all right with that?
Do we reduce that as well?
Yes, I was waiting for that. Good job. We could take 3/18 and what if we divide the top by 3 and the bottom by 3, we get what, 1/6. So we get 3 1/6. Good job, Courtney. Okay, so that finishes up the mess I started yesterday. Now comes the easier part. Hopefully you'll think so. But before we do that, let's just recap for a moment. To add or subtract fractions or mixed numbers, you have to have a common denominator with all the fractions involved, okay? So if you have the common denominator, great, you go for it. You add or subtract the numerators over the common denominator. If you don't have the same denominator, you got to get there by building whatever fractions need to be built. Once you've got the common denominator, you go from there. Now, what we're going to look at next is multiplying or dividing fractions and mixed numbers. The nice thing is, to multiply or divide fractions or mixed numbers, you don't need a common denominator. That should be good news. Woohoo! All right, let the celebration continue. All right, so let's take a look at this example. 3/4 times 7/9. We've already kind of established through example that when you're multiplying fractions, you multiply straight across. 3 times 7 is 21. 4 times 9 is 36. Okay. Now, and if you're thinking, why didn't you? Don't worry, I'm going to come back and do what that thing you're going to say. Why didn't you? Okay, you'll see. 21 over 36. Can I reduce that? Well, 21 is 3 times 7, and 36 is what? 2 times 18, 2 times 2 times 9, 2 times 2 times 3 times 3. So, and again, this is not ultimately the way I'm going to have you do it, but I want to show you the long way so that you'll like the short way. If I offer you broccoli, you won't like it. But if I promise you chocolate cake afterwards, maybe you'll eat the broccoli. Maybe, maybe not. Okay. So in this case, I could reduce the 3's down and I'd have what? 7 over 12. All right. Now, let's go back here and see what's going on there. 3/4 times 7/9. Since you multiply straight across, isn't that the same thing as that? In other words, I could write it in that form, 3 times 7 over 4 times 9. But then couldn't I take this and reduce that down to 1 over 3 and get my 7/12? Even that's too much work. We don't have to go there. Because these are multiplied together, we can just come in here and say a factor on top and a factor on the bottom reduces down, and there's my final answer, 7/12. Bada boom, bada bing. Did I lose anybody there? Okay, so let's take a look at some more examples. 2/3 times 6 over 11. I'm multiplying fractions, so I could reduce the 6 over the 3 to 2 over 1. So now I've got 4 11s. 2 times 2 is 4. 1 times 11 is 11. We okay with that? All right. Let's take a look at another example. 2/9 times 12 over 8. Oh, there's a couple of different things I could do. I could take 2 over 8 and reduce it to 1 over 4. I could take 12 over 9 and take out a 3 and reduce it to 4 over 3. Or I could take 12 over 8 and reduce it to 3 over 2. Any of those first moves are correct. And as to whether one is preferable to the other, that's up to you. Okay. I've got to have a factor on top and a factor on the bottom. Mike, do you have a question? You need to turn your microphone on. Yeah. What?
I still don't get how all that works.
How all that works. Okay.
Yeah, how like
why I can do that?
Why you can do that? Yeah.
Okay, let me convince you. Would you agree that this is equal to 2 over 3 times 3 times 2 times 2 times 3 over 2 times 2 times 2? Now, before you say yes or no, what did I just do? I took 9 and broke it down into its prime factors. I took 12 and broke it down into its prime factors.
Okay.
I took 8 and broke it down into its prime factors.
Yeah.
So would you agree that what I started with on the left side of the equal sign is equivalent to what I started with on the right side of the equal sign?
Yes.
Agree with that? Okay.
Yeah, I can
Now,
see it. Yeah.
since the rule is when you multiply fractions, you multiply straight across.
Right.
Let's take this, but let's put them together, but let's not actually multiply them together. So wouldn't this be isn't that the same thing as that?
It is.
Okay. Now, multiplication is commutative. You can multiply two numbers in either order. Okay. So if I wanted to, I could take this 3 and I could move it out into the front. You okay with that?
Right. Yeah.
Now,
I'm okay with that.
since I can take this and put it together, I can take this and pull it apart. I could separate off that.
Right.
What's 3 divided by 3?
1.
1. I could separate off that. What's 2 divided by 2?
1.
What's 2 divided by 2?
1.
You see what's happening?
Uh-huh.
So I'm accomplishing this, but without going through all of this stuff. I'm saying because this is true and this is true and this is true, I can go back here. And I can say, oh, 2 over 8 is 1 over 4. Taking a 2 out of both. 12 over 9 is 4 over 3. Taking a 3 out of both. With me? 4 over 4 is 1 over 1. Taking a 4 out of both. 1/3 done. Are you convinced?
I'm convinced.
How about the rest of you?
That's crazy.
I'm doing the same thing as over here, but this is what's known as pre-reducing. You're making things smaller before you multiply them together. Now, is it wrong to do all of this? No, but I'll just look away and go, oh, I can't believe you're doing all that extra work. You really want to get used to this process. Okay. All right, here we go. 1/7 times 14 over 6. Okay, I could reduce 14 over 7, or I could reduce 14 over 6. Either way, but one has to be in the numerator, one has to be in the numerator. Can't talk. Okay, how about this? 14 over 7 reduces to 2 over 1. Okay. Oh, but 2 over 6 reduces to 1 over 3. So once again, I get 1/3. Final answer. All right with that? Okay. Let's put some negative signs in there, just what you wanted. How about this? Let's see here. negative 17 over 41 times 31 over 15. Okay. Oh, you know what? I wrote that wrong. This is supposed to be a 5. Time to put on the respectacles. All right. Yes, that's correct. Okay, so can I do anything? 17 is prime. Oh, you know what? 3 times 17 is 51. So could I reduce those? Good job. No, I can't. They're on the same line. It's got to have one on top and one on the bottom. I got to get up earlier than this to trick you. It's not going to happen. I'm not getting up earlier. I'm a lazy bum. All right. There's a rule that I haven't told you up until now that maybe you've heard before, maybe you haven't, but it has to do when you're trying to determine whether a number is prime. If you take the digits in the number, the individual digits, and you add them up, and the sum of those digits is a number that is divisible by 3, then the original number is divisible by 3. What's 5 plus 1? So what's 5 plus 1? It's 6. Does 3 go into 6 evenly? Yes. What's 1 plus 5? Does 3 go into 6 even? So 3 goes into 51 and into 15. That might be hard to see other than, oh, 3 goes into both. Okay. So let's see, 51 over 15. 15 is 3 times 5. 51 is 3 times what? 51 divided by 3. Oh, 17. That's kind of tricky there, but do you see what I did? You don't like it, but do you see what I did? So I can reduce this to 17 over 5. This one's ugly, isn't it? The 17s don't reduce because they're on the same line. So what have I got to do now? Well, I've got to take negative 17 times 17. Let's see. 49, carry the 4, 11, 0, 1, 7, 289. So this is negative 289 over 41 times 5, which is 5, 205. Okay. Now, I started with fractions, so I'm just going to leave it as a fraction. You could change it to a mixed number if you want. Then the question is, well, can I reduce that? No, and I am sure of that because if I look back here, nothing reduces there. So multiplying it together, still nothing would reduce. That was kind of a horrendous one. My apologies. Okay, let's look at one that's not quite so horrendous. Oh, you may not agree with me. Let's see here. 18 over 25 times 75 over 4. Okay. So do you see anything there we could pre-reduce? What? The 2? So we could take a 2 out of this and a 2 out of that. Anything else we can take out? You're going to need more than fingers and toes for this one.
25 and the 75.
25.
Excellent. Yeah. You know, you could do this. You could go, I can't get my toe up there. I've been told that at one point in my teaching career, I stood up on the table, took my socks and shoes off in order to count. I don't know if I could get on the table anymore, but I could believe that I would have done that. So 75 divided by 25 is 3. 25 divided by 25 is 1. Can I do any more pre-reducing? No. 9 times 3 is 27. 1 times 2 is 2. Okay. And the directions for this particular problem says not mixed numbers, so you would leave it like that. Okay. How we doing? Is it getting better a little bit? All right, excellent. Next one. Let's see here. Hang on. I need to find an example. Here we go. 3 times 4 7/12. Now, you cannot take the 3 and the 12 and reduce it yet. To multiply mixed numbers or a mixed number, you need to change it into an improper fraction. Okay, got to do that first. So 4 7/12. 4 times 12 is 48 plus 7 is 55. So this is 3 times 55/12. So let me say that again. To multiply a mixed number by something, change it to an improper fraction first. Okay? Now, oh, and this 3 that's there, it's in the numerator, right? So there's an implied over 1. If you need to put that little crutch there to help things along, go for it, okay? I call it a crutch because if you have a broken leg, you need a crutch. But once your leg heals, get rid of the crutch. So once you get to where you don't need that, don't bother with it. Okay. 3 over 12 is 1 over 4. 55 and 4 have no common factors to reduce out. So final answer, 55/4. All right. Let's take a mixed number times a mixed number. 2 5/9 times 4 1/2. So what's my next move? I'm going to ask you to do something that's what?
Change the mixed number.
Yes, I'm going to ask you to do something very improper. That's not very nice of me, but yes. What are you going to do? Change those mixed numbers into
Improper fraction.
Thank you. Thank you. I know it's like pulling teeth trying to get you folks to respond, but you just want to sit back and watch the movie and eat popcorn. Okay, fine. All right. Mention my name at the concession stand. You'll get a 2-for-1 deal. Okay. So 2 5/9. 2 times 9 is 18 plus 5 is 23. So we get 23/9. Okay. 4 1/2. 4 times 2 is 8 plus 1 is 9. 9/2. If you're hoping that someday my jokes get better, not going to happen. Sorry. Worse, maybe, but not better. All right, we okay so far? So now we're going to come in and get rid of those. And we've got 23/2. Now, if there were no instructions saying not mixed numbers, I would change it back to a mixed number because our original problem was in mixed numbers. But in this part of WAMAP, it's saying not mixed numbers, so I would leave that answer. Okay. All right, now we're almost done. We've looked at multiplying fractions and multiplying mixed numbers. We have to change the mixed numbers into fractions first. What about dividing fractions? Okay. Well, here's the deal. Dividing by a fraction is like multiplying by the reciprocal. or as I like to call it, the refliprical, because that's what you do. 4/15 becomes 15/4. So dividing by 4/15 is equivalent to multiplying by 15/4. So the reciprocal, you flip the thing over, numerator and denominator, okay? Once you've got it as a multiplication problem, then you go back and do what we've been doing for the last 20 minutes. You multiply straight across, you pre-reduce when you can. 15/5 reduces to 3/1. 2/4 reduces to 1/2. Final answer, 3/2. So to divide fractions, dividing by a fraction is like multiplying by its reciprocal. Okay? How about this one? 5/2 divided by 10/15. So that's going to be 5/2 times 15/10. Now I can come in and pre-reduce if possible. Let's see. I could do the 5 and the 10 or the 15 and the 10. Either one. I'll do the 5 and the 10. So this is going to be 1/2. That's as far as I can go. So I've got 15/4. How are we doing? Okay. Dividing by a mixed number is like multiplying by its reciprocal, but oh, be careful. The reciprocal of a mixed number, that's a tricky thing. You don't just take the fraction part and flip it. So what you've got to do, you've got to change all the mixed numbers into fractions first. So 4 1/8. 4 times 8 is 32, plus 1 is 33/8, divided by 5 times 2 is 10, plus 1 is 11/2. Okay, so I've changed the mixed numbers into improper fractions. But now I'm going to rewrite that. Dividing by 11/2 is like multiplying by 2/11. But change it into the improper fractions first, because otherwise you might think that this is 4 and 8/1 and 5 and 2/1 and that. No, I guess it's reciprocal. Now I can come in and pre-reduce. 2/8 is 1/4. How about 33/11? Does that reduce? What goes into both? 11? 11? Well, 11 goes in, so this would be a 3 and this would be a 1. Final answer, 3/4. Okay. Now, I want to look at one more example here. Or was you still looking at that? Here's looking at you, kid. All right. Let's say I've got this. I've got 8/5 divided by 6. That would be 8/5 times, what's the reciprocal of 6?
1/6.
Right, because there's an implied 1 here, so this would be 1/6. Just wanted to make sure you were good on that. So then I could take a 2 out and get a 4, take a 2 out and get a 3, and I get 4/15. All righty, we made it. Hopefully no one died along the way. So you can wrap up the 1D and work on 1E, which hopefully you'll find a little bit easier multiplying and dividing fractions than adding or subtracting fractions. I will be back at 1:15. Should you care to join me for questions, or if you have questions and can't make it then, email me and I will get back to you when I can. All right. Okay, have a great day. Thanks for stopping by. I'm going to stop the recording